In this question, we have to arrange following phenols in decreasing order of acidic strength. Now, acidic strength depend on stability of conjugate base. In this case, stability of phenoxide ion. If conjugate base is stable, then acidic strength will be high. Now, conjugate base is anion, and stability of anion depend on minus M, minus H and minus I effect, while plus M, plus H and plus I effect decreases acidic strength. Now in first case, phenol is taken. Now phenol can be taken as reference because no other electron donating or withdrawing groups are present, so it is taken as reference. Now in first case, fluorine is present which have minus I and plus M effect, but for halogen inductive effect is stronger than mesomeric, so it is overall electron withdrawing and it will increase acidic strength. Now in third case, Cl is present. Now Cl will also have minus I and plus M effect, and for halogen inductive effect is stronger than mesomeric. Where inductive or mesomeric both are present, then out of FrCl, Cl is more withdrawing than fluorine. So parachlorophenol is more acidic than parafluorophenol. In fourth case, NO2 group is present which have very strong minus I and very strong minus M effect, so it is overall electron withdrawing, and due to its electron withdrawing effect, fourth is most acidic, then third, then 2 and then 1, and hence correct answer is C. In this question we have to find which of the following given benzoic acid is weakest acid. Now acidic strength depend on electron withdrawing group. Now if electron withdrawing groups are present, then acidic strength will be high. Acidic strength depend on stability of conjugate base. Conjugate base is anion which will be stabilized by electron withdrawing minus M, minus H and minus I effect, while it will be destabilized by plus M, plus H and plus I effect. Now in first case, benzoic acid is present. In this molecule, no electron donating or withdrawing groups are present, so it will be taken as reference. In second case, OH group is present which is having minus I and plus M effect. Since OH is having mesomeric and inductive both, and mesomeric is stronger than inductive, hence OH will be overall electron donating. In third case, OH is present at meta position, and if two groups are attached at meta position, they will only have minus I effect. Due to plus M effect of OH is not applicable on COOH, so only minus I effect is applicable in this case. In option D, OH is present at ortho position of COOH, so here ortho effect is applicable, and all ortho substituted benzoic acid are more acidic than meta and para isomer. After removal of H positive ion, now this carboxylate ion will be extra stabilized by hydrogen bond. So among given four, D is most acidic. After D, C will be more acidic because it will increase acidic strength due to minus I effect. Then reference A, and B is least acidic because of its electron donating behavior of OH group, and hence weakest acid is para-hydroxy benzoic acid, and correct answer is B. In this question we have to find which of the following compound will react with NHSO3 to give CO2. So any molecule which is having pH value equal to 7 or pH less than 7 will always react with NHCO3 to produce carbon dioxide gas. Now first is squaric acid, and squaric acid is one of the most organic acid. Now second case, COOH is present. Now in third case, COOH is present. Now if COOH is present, now pK value will be approximately 4. So second and third are having pK value 4, and any molecule which is having pK value less than 7 will react with sodium bicarbonate NHCO3 to produce CO2 gas. Now squaric acid is having pK value approximate between 1 to 0. It is very strong acid. So all these acid will react with sodium bicarbonate to produce CO2 gas, and hence correct answer is A. Which of the following is the strongest base? So we have to find which one of the following is the strongest base in the given compound. Now basic strength depend on availability of lone pair on nitrogen atom, availability of lone pair on nitrogen atom. So in any case, if lone pair is involved in resonance, then basic strength will be decreased. So basic strength is inversely proportional to lone pair involved in resonance. Now basic strength also depend on electronegativity of atom. If atom is more electronegative, then its tendency to donate pair of electron will be less. So basic strength is inversely proportional to electronegativity. Now in first case, nitrogen lone pair is not involved in resonance, but minus I effect of phenyl group is present, and minus I effect will also decrease basic strength. So any electron withdrawing group, if electron withdrawing group are present, they will decrease basic strength, and any electron donating group will increase basic strength, like plus M, plus H and plus I will increase basic strength, while minus M, minus H and minus I will decrease basic strength. So now in first case, minus I of phenyl group is present, so in this case basic strength is comparatively less. Now in second case, lone pair is involved in resonance, and if lone pair is involved in resonance, then basic strength is very low. Now in option C and D, both nitrogen lone pair is not involved in resonance. If lone pair is present on sp2 hybridized atom, then it is perpendicular to other plane, so it will not involve in resonance. But here lone pair is present in sp2 hybridized atom, and with increasing electronegativity of nitrogen atom, its basic strength will be decreased. While in option D, nitrogen is not involved in lone pair. Nitrogen lone pair is present in sp3 hybridized atom, means on less electronegative atom, and other carbon or alkyl groups are electron donating. Hence D is most basic among given compound, and hence correct answer is D. In this question we have to find when 1 mole of NaNH2 is treated with the molecule, which of the following product is formed. So NaNH2 is very strong base. Now this strong base will react with that acid which is most acidic. So out of COOH, phenol, alcohol and alkyne, benzoic acid is most acidic because its pK value is approximately 4.21. Now second number, phenol is most acidic because it is having pK value approximately 10. Now alcohol pK value 16 and alkyne pK value 25. So COOH group is most acidic, and hence COOH will be converted to salt, while other groups will retain as such, and hence correct answer is D, in which COOH is converted to COONA while other groups are retained in the molecule. In this question we have to find which of the following has most acidic proton. Now acidic strength of proton depend on stability of conjugate base formed after removal of H positive ion. Now in first case, after removal of H positive ion, CH3CO CH2 negative ion is formed, which is stabilized by resonance of carbonyl group. Now in second case, CH3CHO, again CH2 negative CHO is formed, which is stabilized by one carbonyl group. In third case, when H proton is formed, released, and carbanion is formed, now this carbanion is extra stabilized by resonance of two carbonyl group, while in fourth case, after removal of H positive ion, the carbanion formed is stabilized by electron withdrawing group of electron withdrawing carbonyl group. So it is stabilized by 3 electron withdrawing group, and hence fourth is having maximum stability, and hence correct answer is D. This molecule is having various nitrogen atom which are having lone pair. Now we have to compare which of the following is most basic and which of the following is least basic. We have to arrange these nitrogen atom according to basic strength. Now, if lone pair is not involved in resonance, then basic strength will be high. Now in case A, nitrogen is having localized lone pair which is comparatively more basic, and this nitrogen atom donates its electron to other nitrogen, and hence electron density is maximum at A. This is imidine system, and now this group part will be most basic among others. So A is most basic. Now out of B and D, both are involved in resonance, but due to SIR effect, this group change its plane, and due to SIR, now nitrogen lone pair are not involved in resonance. So out of B and D, B is more basic. Now in case of C, nitrogen is having resonance with carbonyl group. Now this is amide group, and lone pair of nitrogen are mostly shifted in oxygen atom towards more electronegative atom, and hence C is least basic, and hence correct sequence is A, B, D, and then C. In this question we have to find correct basic strength of given bases. Now basic strength depend on availability of lone pair. If lone pair are available on nitrogen atom, then basic strength is comparatively high. Now in first case, there are two nitrogen atom. Now this nitrogen is having delocalized lone pair. Now this nitrogen is localized. This lone pair is involved in resonance, while this nitrogen lone pair is not involved in resonance. And in this case, this nitrogen increases electron density on other nitrogen atom, and this part of the molecule can be regarded as imidine system. So first is most basic among the given. So first is most basic. Now in second case, now lone pair are part of aromatic ring. If lone pair are donated, then there is loss of aromaticity. So second will be least basic. Out of 3 and 4, 3 is 2 degree amine, 4 is 3 degree amine, and 3 degree amine are comparatively less basic than 2 degree amine. 2 degree amine is more basic than 3 degree amine, and hence 3 is more basic than 4. So correct sequence is 1 3 4 2, and hence option A is correct. In this question we have to compare basic strength of given anion. Now basic strength of anion can be compared on the basis of conjugate acid. A more strong acid, a stronger acid will have weaker conjugate base. So now if we compare acidic strength of given compound, so if HF, H2O, acetylene, ammonia, alkene and alkane are taken, And if we compare their acidic strength, now HF is having pK value approximately 4, H2O pK value approximately 16, alkyne 25, ammonia almost 37, alkene 40, or alkane approx 50. So if acid is strong, then its conjugate base will be weakest. So HF is strongest acid among these, and ethane is weakest acid. So F negative, out of F negative, OH negative will be stronger base, and if we form their conjugate base, now CH3 CH2 negative will form strongest base, and hence correct answer is C. In this question we have to find correct order of deprotonation of labeled hydrogen atom. Now in first case, SO3H group sulfonic acid is present, and if sulfonic acid release H positive, now sulfonate anion is formed. Now this sulfonate anion is having 3 equivalent resonating structure, so it will form most stable resonating structure. Now in the case of carboxylate ion, 2 equivalent resonating structures are formed, so it will be comparatively less stable. So first is most acidic, then 4. Now out of 2 and 3, when hydrogen is deprotonated from carbon which is attached with NO2 group, now CH negative NO2 is formed. Now this NO2 will stabilize negative charge. NO2 is having stronger minus I and minus M effect, so it will stabilize more, while CH negative CHO is least stable because CHO is comparatively less electron withdrawing, it is having less minus I and less minus M effect. So first is most acidic, then 4, then 2, and then 3, and hence correct answer is C. In this question we have to find which of the following is maximum basic in nature. So now basic strength depend on availability of lone pair. If lone pair are available on nitrogen atom, then basic strength will be high. So in first case, lone pair atoms are delocalized, involved in resonance, hence basic strength is less. While in option B, nitrogen lone pair are not involved in resonance. In option C, again nitrogen lone pair are involved in resonance. In option D, lone pair is involved in both sides of benzene ring. So B is most basic because its lone pair are not involved in resonance, and hence correct answer is B. In this question we have to find correct acidic strength. Now acidic strength can be compared on the basis of stability of conjugate base. If conjugate base is stable, then acidic strength will be high. Now in first case, in case of squaric acid, after removal of H positive ion, now this anion is formed which is aromatic anion and involved in resonance, so most stable. So first is most acidic. Now out of carbonic acid and phenol, which is also called carbolic acid, now carbonic acid will form 3 equivalent resonating structure, hence it will be comparatively less acidic than squaric acid but more acidic than phenol. Now phenoxide ion is only involved in resonance but not equivalent resonating structures are formed. In fourth case, now negative ion is involved, comparatively less resonance, hence acetone is least acidic. Now squaric acid is having pK value between 0 to 1, phenol is having pK value approximately 10, carbonic acid 7 and ketone 18. So squaric acid is most acidic, then carbonic acid, then phenol, and acetone is least acidic, and hence correct answer is fourth, 1, 3, 2 and then 4. In this question we have to find which of the following nitrogen is most basic. Now if we take first nitrogen, now this nitrogen is part of aromatic ring, and if this lone pair is donated then there is loss of aromaticity, hence one will be least basic, it will not be donated. In second and third, in second case nitrogen lone pair is localized, and if nitrogen lone pair is localized it is always more basic. Localized are always more basic, so 2 is more basic. In case 3, nitrogen lone pair are shifted towards more electronegative oxygen, and if lone pair is involved in resonance then its basic strength will be low. So out of 2 and 3, 2 is most basic, then 3 and 1 is least basic, and hence correct answer is B. In this question we have to find which of the following is least basic. Now basic strength depend on availability of lone pair. Any effect which increases electron density on nitrogen atom will increase basic strength. So we can write electron donating group increases basic strength, while electron withdrawing group decreases basic strength. Now plus M, plus H and plus I will increase basic strength, while minus M, minus H and minus I will decrease basic strength. Now in first case is 3 degree amine, or again 3 degree amine, 3 degree amine, all the amines are 3 degree. Now here reference benzene is present, no other electron donating or withdrawing groups are present, while in option B CH3 is present which act as electron donating due to plus I and plus H effect. In option C CHO is present which is having very strong minus I and minus M effect, so it will decrease basic strength by decreasing electron density. In option D minus I and plus M are present, but halogen are overall electron withdrawing, so halogen will decrease basic strength. So now in given compounds, B is most basic, then A, then D, and C is least basic, and hence correct answer is C. In this question we have to find which is more basic in following pair of compound. Now in option A, first molecule is having flipping, and due to flipping in open chain electrons are equally distributed above the plane and below the plane, while in option second conformation is locked, so lone pair are directed in one direction, so basic strength of second is greater than first. Similarly in option B, in this case nitrogen is present in open chain, here nitrogen present in ring, so in first case due to flipping basic strength will be comparatively low, while second is more basic than first, so in B again second is more basic. Now in first case here in urea lone pair of nitrogen is involved in resonance due to basic strength of nitrogen atom is decreased, while in second case now each nitrogen atom is having lone pair. Now these two lone pairs are involved in resonance, and these two nitrogen atom increases electron density on this nitrogen. This compound is known as guanidine, and guanidine is one of the strongest base, so in C also second is more basic. So in all the cases second is more basic than first, and hence correct answer is D. In this question we have to find which of the following reaction is not possible. So for any reaction in which weak acid or weak base are formed in forward direction, those reactions are possible in which weak acid and weak base are present in product side. So if strong acid is being converted to weak acid, or base or strong base are converted to weak base, those reactions are possible. Now in first case, HCl is strong acid having pK value between 0 to 1. Now CCH3COOH is formed as a product which is having pK value 4. So in this reaction, weak acid being formed in forward direction, so this reaction is possible, this reaction is feasible. In second case, from sulfonic acid, alkyne is formed. Sulfonic acid is having pK value approximate 0 to 1. Now acetylene is formed which is having pK value 25. So then again, moving forward direction, weak acids are being formed, so this reaction is also possible. In third case, now alkyne is present in reactant side which is having pK value 25, and in product side phenol is formed. Phenol is having pK value 10. So weak acid is getting converted to a strong acid, so this reaction is not possible. In fourth case, alkyne is present which is having pK value 25 in product side. Ammonia is present which is having pK value 37. Now the compound which is having lower value of pK are more acidic, so those reactions are feasible in which weak base or weak acids are formed. So in option A, B and D, moving forward direction, we are getting weak acid, while in C we are getting strong acid in moving forward direction. So this reaction is not feasible, and hence correct answer is C.